As promised, I am making a video on our solution key for our quiz 4. So let's jump into it. Our first question, we are asked to solve our equation for x by using our like bases. So we have 64 times our 4 raised to the 3x is equal to 16. Let's first utilize our inverse operations. Divide both sides by 64. And 16 divided by 64 is just 1 over 4. What is 1 over 4 with the base of 4? That's just 4 to the negative first power. Our bases are now the same, so we can set our exponents equal to each other. And so we essentially have just 3x is equal to 1. Last but not least, let's divide both sides by 3 so that we get our x value. Forgot the negative 1 here. But our x value is equal to negative 1/3. And we're done. Let's go ahead and move on to our question 2, where we are using logarithms. We want to solve this exponential equation. We're going to end up putting our final result of x in terms of natural logs. So let's first use our inverse operations, and we're going to subtract both sides by 6 so that we have e to the negative 3x is equal to 38. And now we'll use our knowledge of logarithms. We'll take the natural log of both sides. Utilizing our power rule, we end up getting 3x times our natural log of e is equal to the natural log of 38. Natural log of e is just 1. So we get negative 3x on the left-hand side is equal to our natural log of 38. And then we want to solve for x, so we're going to divide both sides by negative 3, which gives us our final answer of x to be negative natural log of 38 all over 3. And we're done. Easy enough. Now let's move on to our question 3. We want to solve the logarithmic equation. We have log base 13 of 5n minus 2 is equal to log base 13 of 8 minus 5n. Straight off the bat, our bases are the same, so we can just set the parentheses equal to each other. If you didn't see that, then we can just do the opposite of log base 13, which means we raise our whole left-hand side to our exponent with that base of 13. So 13 to the log base 13. And we do the same thing to that right-hand side. And so 13 raised to the log base 13, those will cancel out. And then indeed we get back to setting what's inside our parentheses equal to one another. Now we're just going to go ahead and use our straightforward algebra to find n by combining like terms and using our inverse operations. And so we get 10n on our left-hand side is equal to 10, which means our n value is just 1. And we're done. Our last question is an exponential model question. And so we're given that the fox population in a certain region has a continuous, so we're going to be using E, growth rate of 6% per year. So our R is 6%, but we want to put this in terms of a decimal. So we have 0.06. E is going to be used here, equals continuous growth. In this case, that's why our R is positive. And then it says, it is estimated that the population in the year 2000 was 11,600 foxes. Find a function P of t that models the population t years after 2000. So t is equal to 0 for 2000, which tells us that's our initial value. And I'll put our initial value, I'll say that's A. Which is 11,600. So the general formula for continuous growth is our A of t is equal to little a times e to the RT. But we want it in terms of P of t. So we're looking at P of t is equal to A times e to the RT. And now we just want to plug in our information that we wrote off here to the side. And when we do, we get our formula, aka our answer, 11,600 times e to the 0.06 t. And we are done. So I hope this was helpful. And yeah, let me know if you have any questions on this. Bye, guys.